The universe is never still. It swirls, expands, collides, and stretches in a cosmic dance so vast that even light itself seems to struggle to keep up. From the blazing hearts of galaxies to the silent vacuum between the stars, everything is in motion, a motion written by invisible hands. The camera of imagination drifts across the Milky Way, billions of stars orbiting a hidden black hole, each one bound by forces older than time itself. Yet, beneath this breathtaking choreography lies a question humanity has never fully answered. What is truly driving it all? For centuries, science believed the universe played by familiar rules. Gravity, the pull that keeps planets in orbit. Electromagnetism, the spark behind light and life. The strong and weak nuclear forces, binding and breaking atoms in the furnaces of stars. Together, these four pillars explained almost everything we could see. Almost. But as telescopes peered deeper into the night, something unsettling appeared. Galaxies were not slowing down as they should. Space itself was stretching faster and faster, as if pushed by a force no one could measure, a force unseen, undetected, yet unimaginably powerful. The known laws of physics began to tremble. What could possibly do this? Whispered astronomers as they watched the expanding cosmos defy every equation. This is where our story begins, at the edge of understanding. Beyond the light of stars lies a mystery that could rewrite everything we know about reality. In this journey, we will explore the forces that built the cosmos, the rules they follow, and the one hidden power that may rise above them all. The silent architect shaping the fate of the universe itself. The story of invisible forces begins, as all great tales of discovery do, with a single question: why does the apple fall? In the late 1600s, under the quiet shade of an apple tree, Isaac Newton glimpsed an invisible truth. What made an apple fall to Earth was the same force that held the moon in orbit. Gravity, unseen, intangible, yet universal. It was the first great revelation that nature's most powerful influences could not be touched or seen, only felt and understood through mathematics. Newton's equations became the foundation of classical physics, a world ruled by predictable laws, by clockwork precision. Centuries later, the universe shattered that certainty. Albert Einstein reimagined gravity not as a pull, but as a curve in the fabric of space-time itself. His theory of general relativity revealed a cosmos where planets, stars, and galaxies were not merely objects in space, they were dancers in a flexible, bending stage. Mass told space how to curve, and space told mass how to move. Suddenly, gravity became poetry, a dialogue between geometry and existence. The universe, it seemed, was alive with invisible conversation, but gravity was only one voice in a grander chorus. As science advanced, three more fundamental forces emerged: electromagnetism, the strong nuclear force, and the weak nuclear force. Together, these four pillars formed the scaffolding of reality. They governed everything from the motion of galaxies to the beating of a human heart. Yet as physicists peered deeper into the subatomic world, they began to wonder, could all these forces be different expressions of one ultimate power? This dream, the theory of everything, became the holy grail of physics. The likes of Einstein, Feynman, Hawking, and countless others chased it through blackboards and equations, searching for the elegant symmetry that could unify all nature under one law. But just as humanity seemed close to finding it, the universe whispered back a riddle. Galaxies spun too fast. Light bent in ways that defied gravity's predictions. The cosmos itself seemed to be expanding, accelerating, as if pushed by something beyond comprehension. In the late 20th century, physicists uncovered the existence of dark matter and dark energy, invisible phenomena that neither emitted nor reflected light, yet dictated the fate of galaxies. The rules we thought governed reality suddenly seemed incomplete, perhaps even wrong. Now, a haunting question lingers in every observatory and laboratory on Earth. If everything we can see, every atom, star, and planet, makes up less than 5% of the universe, what is the rest made of? Perhaps, just beyond the reach of our instruments, there lies a hidden power, silent, unseen, and vastly stronger than anything we've ever known. a force not yet defined by physics, but written deep into the universe's design, waiting for us to discover it. Across the infinite fabric of the universe, an invisible hand is at work, silent, relentless, and unimaginably vast. Astronomers call it dark energy, a mysterious force that defies all logic, pushing galaxies apart, accelerating the universe's expansion, and reshaping space-time itself. It is the unseen architect of the cosmos, a power that does not shine, pull, or interact with matter in any familiar way. And yet, it rules everything. For most of human history, scientists believed that gravity was the universe's dominant power, the great unifier, the sculptor of stars and galaxies. But in the late 1990s, a small group of astronomers looked deeper into the cosmos and found something that changed everything. They were studying Type Ia supernovae, massive stellar explosions that shine with near-uniform brightness, allowing astronomers to measure cosmic distances like cosmic mile markers. The expectation was clear. The farther away a supernova appeared, the slower the universe's expansion should be. After all, gravity, that cosmic glue, should have been pulling everything back together over time. But the data told a shocking story. Dr. Saul Perlmutter, one of the team leaders, recalled, "We were expecting to measure deceleration. What we found instead was acceleration. The universe wasn't slowing down. It was speeding up. In that instant, the known laws of physics cracked open. Something unseen was overpowering gravity, pushing galaxies away from one another faster and faster, as if the fabric of space itself were stretching under an invisible tension. Astronomers named this unknown influence dark energy, not because they understood it, but precisely because they didn't. And its dominance is staggering. When scientists began measuring the composition of the cosmos, they realized that all the stars, planets, and galaxies, everything visible to our eyes and instruments, accounted for less than 5% of the universe. Another 27% consisted of dark matter, a mysterious invisible mass that binds galaxies together. But the remaining 68%, the overwhelming majority, was something else entirely, a form of energy with negative pressure, a property so bizarre it causes the universe to expand ever faster. We live, quite literally, in a universe ruled by the invisible. But what exactly is dark energy? The truth is, no one knows for sure. Scientists have proposed several daring theories to explain it. One possibility dates back to Einstein himself, who once introduced a term into his equations called the cosmological constant, a kind of built-in energy of space that keeps the universe stable. Though Einstein later dismissed it as his greatest blunder, modern discoveries suggest he may have been right all along. If the cosmological constant is real, it means empty space isn't truly empty. It hums with vacuum energy, tiny fluctuations in quantum fields that exist everywhere, even in the darkest corners of the universe. But there's another more dynamic theory, the idea of quintessence, an invisible, evolving energy field that changes over time, shaping the universe's fate like a living force. Dr. Priya Natarajan, a Yale astrophysicist, once described it vividly. Dark energy isn't just a background hum. It could be a restless sea of invisible waves, slowly pushing the cosmos outward in ways we're only beginning to sense. The struggle between gravity and dark energy defines everything about our universe's destiny. Gravity pulls matter inward, forming stars, planets, and galaxies, giving shape and structure to creation. But dark energy pulls in the opposite direction, forcing the cosmos apart. The result is a delicate cosmic tug-of-war, where one side sculpts and the other stretches. Visualize the universe as an enormous elastic fabric. Each galaxy is like a bead on that fabric, and as dark energy intensifies, the elastic stretches, the beads drift farther apart. Billions of years from now, galaxies will grow so distant that their light will no longer reach us. The night sky itself will grow dark and empty, as if the universe is slowly erasing its own story. To understand this hidden force, scientists are now probing deeper than ever before. Through the redshift of distant galaxies, the cosmic microwave background radiation, and the bending of light known as gravitational lensing, Astronomers are mapping how dark energy shapes cosmic structure across billions of light years. The more we measure, the more astonishing and confusing the results become. New tensions are appearing in the data. Measurements of the universe's expansion rate, the Hubble constant, don't agree between early universe and present-day observations. Some physicists suspect that dark energy might not be constant at all, but shifting, evolving, or interacting with matter in ways we can't yet perceive. Others suggest that Einstein's theory of gravity itself may be incomplete, that general relativity might break down at cosmic scales. A few even whisper of wilder possibilities, string theory, extra dimensions, or a multiverse, where dark energy varies from one cosmic bubble to another. What's clear is that dark energy challenges not only our understanding of physics, but of existence itself. Every second, space expands, galaxies drift farther apart, and the visible universe grows larger, all driven by something we cannot see or measure directly. Imagine standing at the edge of a cosmic ocean, watching the tide rise endlessly, knowing that no matter how far you look, the horizon will keep retreating. That is the essence of dark energy, a universe forever stretching, forever escaping our grasp. As the narrator's voice fades, the camera pans across a sea of galaxies, spiraling, glowing, fading into the distance. Their light, traveling across eons, tells a single, silent truth. The greatest power in the universe is not the one we see, but the one we can barely imagine. Orator, calm, cinematic tone. In the vast theater of the cosmos, every star, every planet, every atom of life dances to an invisible rhythm, a rhythm conducted by dark energy. It's not just a cosmic curiosity or a footnote in physics textbooks. It's the force that shapes our destiny. Dark energy determines the grand storyline of the universe, whether it will continue to expand forever, slow down, or meet an unimaginable end. It is the ultimate sculptor of time and fate. Without it, galaxies might someday collapse back upon themselves, returning the universe to darkness. With it, creation keeps stretching outward, forever. Dr. Katie Mack, a theoretical astrophysicist, once described it this way: "We're living inside an experiment that's still running. The outcome will define not just our future, but the meaning of forever itself." As we peer ahead, scientists see several possible endings written in the stars. One vision is called the Big Freeze, an eternal expansion in which dark energy continues to drive galaxies farther and farther apart until stars burn out, planets crumble, and even atoms lose their bonds. The universe would not end in fire, but in silence, a cold, dark, endless night. Another, more dramatic scenario imagines dark energy evolving, growing stronger with time. If that happens, its repulsive force could one day overpower even atomic structure itself, tearing galaxies, stars, and ultimately space-time apart in what physicists call the Big Rip. But there's also the possibility that dark energy could decay or transform, giving rise to new physics, a cosmic rebirth, or even the birth of another universe entirely. Whatever happens, the fate of everything we know, every particle, every heartbeat, rests in the balance between gravity and dark energy. This mystery has become one of the most profound pursuits in modern science, driving humanity to push the boundaries of observation and imagination alike. From orbiting satellites to mountaintop observatories, scientists are pushing the frontiers of discovery, building machines that can see deeper into the cosmos than ever before. The James Webb Space Telescope, Euclid mission, and the Vera C. Rubin Observatory are all part of a global campaign to trace the fingerprints of dark energy across billions of light years. These instruments capture the faint distortions of light from ancient galaxies, tiny clues that reveal how the universe's expansion has changed over time. Meanwhile, supercomputers simulate cosmic evolution with breathtaking precision. Powered by artificial intelligence, they weave together the equations of general relativity, quantum mechanics, and statistical physics, testing thousands of dark energy models to see which one matches the universe we observe. Each discovery brings us closer, Yet somehow, the closer we get, the deeper the mystery becomes. In the quiet corners of this research lies a profound truth, one that transcends data and equations. As humans, we look up at the night sky not just to measure it, but to understand our place within it. And dark energy reminds us that we live in a universe ruled by the invisible and the untouchable. Dr. Brian Greene once reflected, "It's humbling that the very thing keeping the universe alive is something we cannot touch, cannot see, cannot even define." It reminds us that mystery is not the enemy of knowledge. It is the fuel that drives it. Across continents, scientists are working together in a global search for answers. From Europe's Euclid telescope to Chile's Vera Rubin Observatory, from NASA's Dark Energy Survey to Japan's Subaru telescope, this is science without borders. United by one common question: what is driving the universe apart? As data streams in, a new realization begins to form. Perhaps dark energy is not just a cosmic force, but a bridge between the smallest and the largest realms of existence. Physicists now suspect that the same quantum fields flickering beneath the surface of atoms may also ripple across the vast expanse of space-time. In other words, the secret of dark energy could link the microscopic world of particles with the infinite architecture of galaxies. In that connection lies the ultimate implication. When the small meets the infinite, when quantum uncertainty merges with cosmic expansion, we might finally glimpse the unity that Einstein dreamed of, a single, elegant explanation for all that exists. And perhaps in that moment, humanity will realize that the universe was never empty. It was always alive, breathing through the invisible pulse of dark energy. Narrator. Soft. Reflective tone. As we reach the edge of human understanding, one truth becomes clear: the invisible reigns supreme. Nearly 70% of the universe, everything that drives its expansion and defines its fate, is made of something we cannot see, cannot touch, and can barely even describe: dark energy. It is the quiet monarch of the cosmos, invisible, formless, yet infinitely powerful. While stars blaze and galaxies collide in spectacular chaos, it is dark energy that dictates the rhythm of existence, pulling the universe apart with an elegance both terrifying and beautiful. Dr. Priya Natarajan, a cosmologist, once said, "The greatest power isn't in what burns bright, it's in what shapes everything from the shadows." And perhaps that's the lesson the universe is teaching us, that power isn't always loud. It doesn't always roar, explode, or dominate. Sometimes true power is subtle. It expands quietly, patiently, reshaping everything over billions of years. In that silence lies the ultimate strength, unstoppable and eternal. Now, as our eyes turn toward the future sky, a new generation of explorers prepares to continue the quest. Space telescopes like Euclid, Nancy Grace Roman, and Rubin Observatory are charting the universe's grand expansion with precision never before imagined. Each observation brings us closer to the heartbeat of the cosmos, the pulse of dark energy itself. But even as our instruments grow sharper, the universe keeps its secrets. Every answer only deepens the mystery, and perhaps that is the point. The greatest power of all may not be dark energy alone, but the unending mystery of existence, forever pulling our curiosity outward into the infinite.